I'm going to show you how to change out this air door actuator that's on my 2006 Chevy Silverado. This will also work for earlier years of this Silverado as well. This actuator controls the temperature on the driver's side. I got the part on Amazon, and I'll put a link to the part in the description of this video. I first noticed that I was having a problem with this when I started hearing this clicking noise. I also found that when it was clicking, if I changed the driver's side control from cold to hot, that clicking noise would quit. The first thing that we're going to need to do is remove this bottom kick panel. To remove the panel, we'll need to take out 4 screws. We'll need a 7mm socket for that. The first screw is on the far left side of the kick panel and just to the right of the gas pedal, right up here. The next one's going to be right down in here. I moved over onto the passenger side now to get the last 2 screws. The third one's going to be right down in here. And the last one is right there on the far right side of the kick panel. Okay, with the 4 screws removed, we should be able to just pull that panel out of there. So now we'll go ahead and remove the electrical connection. All we have to do is press right here on this black piece of plastic. Push down on it and it'll release it, and you can pull it out. So there's 2 screws that hold this actuator in. Now the actuator sits this way, and the electrical connector went up into this connection point here. So with it sitting that way, you can see that there's going to be 1 screw right here and 1 screw right here. For these 2 screws, I had to use a 7/32 socket. A 6mm socket was just a bit loose, and a 5mm was too small. Okay, here's the old one on the left, there's the new one. They look like they're the same part. Before we put the new one in, something we need to take note of is the position of this plastic shaft here. This one lines up with the large notch in the middle, but this one is way to the right. So if we look on the other side, you can see that there's a flat spot in here, so that this can only go on the shaft that's coming off of the door in a certain position. They have to be lined up. This one is not. So we'll need to take and get down, and we'll have to change the position of the shaft on the door so that it lines up more correctly with this, which is straight across. So here's the shaft from the door, and you can see the flat spot right here, and you can see that if you look at it from this post to this post, if a line were drawn in between it, the new one, the flat spot is kind of parallel with that line. So we just need to turn this so that the flat spot lines up the same way. Just something close. Once you get it started, it should fall right into place. Okay, so we just need to make sure and get the white collar coming off of the motor lined up with the shaft coming off the door. And then just push it all up. Just like that. Alright, we have both screws back in. Now we'll just reconnect the electric wire to it. The kick panel is back on. I've got the air conditioning turned on, and now I'm going to check it and make sure that the temperature control is working properly. Right now I've got cold air coming out. I'll go to the hot side, and there it is, hot air. Perfect. For a little fun, let's tear into this thing and see what it looks like inside. So keep watching. Alright, let's tear into this Actuator. This came off my 2006 Chevy Silverado, and this controlled the temperature on the driver's side. So we've got some tabs on the side that will pull open. So we've got a circuit board, we've got a motor, a bunch of gears, and down inside I can see some brushes. So this is either a switch or a potentiometer. So we'll start removing the gears. Looks like there's a bunch of lubrication on the gears. And that is definitely brushes. So right off the bat I can see, since we have a set of mechanical brushes here, that could potentially be a problem there if they get dirty. That could cause it to be intermittent. And if it's not making good contact, the motor might overdrive it and push it too far, and that could be the clicking that I always hear. So we'll do some testing and see if that is a variable resistor in here, or a potentiometer as they're called. So it looks like we've got some test points on the circuit board. That's what these solder spots are. So if I measure between this one and this one, it should tell me what the resistance is on this piece right here. Okay, I've got my meter set up to read ohms, and so now we'll put the first probe on the first test point, which is right there, and the other one right there. So there we go. It's a little over 8,000 ohms. So that is a variable resistor, or a potentiometer. So this inside one is the common point, and this outside is the resistance. So you've got one side of it here, one side of it here. So if I put the brushes back in, I should be able to read it while I'm turning it. So I've got my two probes on two different test points. One that connects to that inner ring that I showed you, the other one that connects to one side of the outer one. So theoretically now I should be able to turn this and it should change the resistance. Right now it's showing about 3,500 ohms. So let's start turning it. Oh yeah. So if I turn it this way, the resistance goes up right at a little over 8,000 ohms. So if I go the other way, now it's coming down. It'll probably get close to zero. Oh yeah. There we go. Yeah, it's down there close to zero. So this is definitely a potentiometer. So if you had to fix this thing yourself because you couldn't get a new one right away, this might be a good place to check. Take it apart, pull it out, check and make sure that these brushes are clean and that they're not bent. And then look on these two rings down here and make sure they're clean. But be careful when you wipe them off. I think they do have dielectric on them. But just make sure there isn't any gunk or anything on there. And that might be all it takes to get this thing going. I did a little research on some of the parts and I looked up these part numbers, and this is a dual op amp. What that does is it actually drives this motor, plus it gives it the capabilities to reverse or go forward depending on which way the door has to go. So I went out to my truck and I took some readings on the plug coming off the controller on the dash, and I read the voltage measurements on here, and this one is 12, this one is 2.5, which is a reference voltage for this. This is ground, and these two are feedback signals. It actually gives the resistance that this is currently in back to the controller. Plus, this will tell it to reverse the motor. So we'll set up a power supply and hook it up and see if that motor turns on. Alright, so we got one channel set up for the 12 volt side, and we'll set this one up for 2.5 volts. That's that reference voltage that we were looking at. And I hooked up a couple of small jumper wires so that I can hook the power up easier. Alright, so we've got the ground and the 2.5 volt reference voltage hooked up. And so now this is the 12 volt, and the gray wire that I've got hooked up goes onto the board where it was showing 12 volts in my truck. So we'll hook it up. Oh yeah, there you go, motor's running. So now I'm going to hook up this orange wire, which connects to the board where, from what I can see on here, and I follow it up to this op amp, this is what's going to tell it most likely to reverse. So let's check it out. Oh, yep, sure enough. I don't know if you can see that very well, but it's, when I apply it, it goes one direction. When I take it off, it goes the other. That way it can control which direction the door goes. Okay, I brought it in, get a close-up of it. Now I'll hook the wire back up and you'll see it reverse. Well, I think electrically this thing is 100%. I don't see any problems whatsoever. I think the problem was I had dirty brushes in here. And I think cleaning those off was all it needed. So if you're in a pinch and you need to fix your own, check that out. That could be the whole entire problem. This one has 250,000 miles on it, so I guess it's bound to get dirty sooner or later. Well, now we know what it looks like inside. That was fun.